Is your battery pack assembly line stuck on two compliance gates? High-voltage cells fear electrostatic short. They need ESD protection end-to-end. And the OEM wants VIN code and battery serial double-bound for traceability, so a recall can pinpoint the exact batch. Pick the wrong handling solution and you fail both. AGV or robot? See the real problem first. A single pack weighs 300 to 500 kilograms. Handling needs both strength and precision. One electrostatic discharge can scrap a high-voltage cell. VIN double traceability isn't just logging a location. It must bind to every assembly action. And mixed OEM line switch models, so the solution has to follow. The answer isn't either-or. AGV solves station-to-station logistics, but its positioning is only plus-minus 10 millimeters. It can insert a pack. A heavy-load robot positions to plus-minus 0.2 millimeters, precise enough to drop it in. The right architecture is AGV for logistics, robot for precise assembly, each to its job, not replacing the other. 3 cores of the robot solution. First, plus-minus 0.2 millimeter precision. Even a 500 kilogram pack inserts cleanly. Second, dual-layer ESD protection. Body grounding plus an anti-static coating embedded in the gripper, meeting IEC 61340. Third, every assembly action binds to the VIN code and battery serial, so a recall pinpoints the affected batch in hours, not weeks. Watch the demo. The heavy-load robot picks a battery module from the AGV transfer point. 6 axes coordinate to adjust pose, aligns to the pack frame, and drops it precisely. The gripper releases and returns, steady cycle. No human touches the high-voltage cells. Static, positioning, and traceability all happen in one motion. By the numbers. AGV, plus-minus 10 millimeters, logs location only. Robot, plus-minus 0.2 millimeters, bound to every assembly action. AGV usually has no ESD protection. The robot has dual layer. Assembly cycle, 45 to 60 seconds. Logistics to the AGV, precision and compliance to the robot. That's the right answer for a dual compliance line. This architecture isn't only assembly. The AGV plus robot division extends to end-of-life battery cascade use. Vision identifies the pack model. The robot extracts modules and sorts them by grade into second life or dismantling and recycling. Battery makers, OEM battery shops, and energy storage cabinet plants all share the same precision plus dual compliance foundation. The core of battery pack assembly isn't how much weight you can move. It's whether you hold placement precision, ESD protection, and VIN traceability in a single motion. Your battery line. How do you protect against ESD? How do you bind the VIN? Still hoping one AGV does the whole job?